Hi everyone. In this screencast, I'm going to be talking about properties of ionic substances, and I want us to be able to explain these properties based on the structure of ionic substances. So we should recall that all ionic substances exist in a crystal lattice structure. The most common ionic substance that we deal with every day is table salt, but there's all sorts, and they all have this crystal lattice structure with cations and anions alternating. So in this case, our yellow is our chloride anions, and our red is our sodium cations. And notice that the sodium cations are all surrounded by chloride anions and vice versa. Okay. So, what are some properties of ionic substances? Well, there's a few big ones. One is that they're brittle. And we say that they're brittle because when they're hit with a hammer, like charges align and repel. We say that they conduct electricity when they're liquid, gaseous, or when they're dissolved, but they do not conduct electricity as solids. And then they have a high melting point because ionic bonds are very strong bonds, and there's a force of attraction that's very strong between ions. I'm going to talk about melting point in a different screencast. In this one, I'm going to focus on brittle and conductivity. So why are ionic compounds brittle? Well, to really show it, we should draw a particle diagram for ionic compounds, and you should know how to do this. When we're drawing a particle diagram, our cations should be alternating with our anions. So I'm going to show plus for the cations and minus for the anions. And I'm going to draw my particle diagram 3 by 3, just so that we can get a sense of what this ionic substance looks like. Okay, so here's an ionic substance, and remember we have cations and anions. Now let's imagine that we're hitting this with a hammer. If I'm hitting this with a hammer, let's say that I hit the hammer right here, okay? I'm going to hit down on this cation that I just pointed an arrow to. What that means is that this column of ions is going to shift down. This whole column is going to shift down when I hit it with a hammer. And when that happens, my cations are going to end up next to my other cations. This is going to end up aligning with this. This is going to end up aligning with this. And when that happens, these ions are going to repel each other, and that is going to cause this whole column to break off. So when I hit an ionic compound with a hammer, I have these columns moving that cause like charges to align and repel, and that's going to make my ionic compound break. What about conductivity? If we look at the particle diagrams for different ionic compounds, we should consider what they look like when they're solid, when they're liquid, or when they're a gas, or when they're dissolved. So we've already looked at solids, and the one on our far left here is solids. And when our ionic compounds are solid, our particles are not moving. And this is why ionic compounds cannot conduct electricity, because those charged ions are locked in place. And because they can't move, they can't conduct. In order for something to conduct electricity, charged particles have to be able to move. With liquids and gases, our particles are moving. So if you took salt and you melted it, those ions would now be mobile. And when you then tried to run an electric current through that liquid salt, it would carry that electricity because those ions are capable of moving to carry that charge. Same thing with a gas. When you dissolve salt, you're going to have those particles in the lattice become surrounded by water molecules. And that means that they are once again going to be made mobile, right? When something is dissolved in solution, it's surrounded by moving water molecules, and it is able to move itself. So if we look at that diagram on the far right, we can see that my positive cations and my negative anions are removed from the crystal lattice by the water molecules, and that makes them mobile. So for my liquids or gaseous ionic compounds, they can conduct electricity, or when they're dissolved in water, because in all those cases, the ions are mobile. But for my solid ionic compounds, they cannot conduct electricity because the ions can't move.